graphing cosecant. So let's think about our values that we did for sine. What is the sine of 0? That should be quick, guys. What's the sine of 0? 0. We're just filling in the chart here. What's the sine of pi over 6? A half. What's the sine of pi over 4? Root 2 over 2. The sine of pi over 3. Okay, sine of pi over 2. 1. Sine of 2 pi over 3. Mumbled, root 3 over 2. Okay, sine of 3 pi over 4. Good. 1/2. Sine of 5 pi over 6 is a half. Good. And what about the sine of pi? 0. Okay. So, if I want to turn all of those into cosecant values, what do I do to them? Yeah, just find the reciprocal. Well, what's the reciprocal of 0? What? Undefined. Good save there. Undefined. Okay. What's the reciprocal of 1/2? 2. Good. We didn't mess that one up. All right. The reciprocal of root 2 over 2. Root 2. Good. Reciprocal of root 3 over 2. 2 root 3 over 3. All right. Reciprocal of 1. Okay. Reciprocal of root 3 over 2. Okay. Yeah, we just did it. 2 root 3 over 3. Okay. Reciprocal of the next one is just root 2. What about the reciprocal of a half? 2. And the reciprocal of 0 and 1. Okay. So we remember sine and cosecant, they're connected. That's not bad. Okay. We are going to go ahead and sketch the graph of sine of x on here to begin with. So I'm going to label the x-axis just like we did last time. This would be pi over 2, pi, 3 pi over 2 and 2 pi, positive 1, negative 1. And let's get our sine graph in there. Hopefully the parent graph is becoming pretty automatic for you. And I'm going to do the left side also. That's not hard, right? Okay. If that is hard, please don't give me more hard time. All right, I'm going to change colors just to make it a little more obvious that I'm graphing something else. And we're going to graph a cosecant right on top of the same graph. So let's look at our values here. When I'm at 0, I get undefined for cosecant. What do you think that is on the graph? What? Asymptote, okay? Sometimes it's a hole, but with these, it is going to be an asymptote. So, at 0, I'm drawing an asymptote. Okay? All right, we're going to skip over to pi over 2 then. So, pi over 2, what is the value of cosecant? 1. So, those dots overlap. So I'm going to put my green dot right on top of there. Okay, what about at pi? What am I doing? Okay, so that's the extent of our 0, pi over 2, and pi from this chart, but let's look at our graph and keep going. You see how it overlapped with the maximum of sine? What do you think is going to happen at the minimum? Yeah, same thing. Just think about it. This is -1. When I flip -1, what do I get? -1. So that point is shared. And what about at 2 pi? What's going to happen? Asymptote, yes. Can you draw some things on the left side then? Yeah, anywhere it's 0, I get an asymptote because that's undefined when you flip it. The 1's overlap and the -1's overlap. So we don't really have a shape yet, but we've got some points. All right, I'm not going to make you plot a bunch of these other points. I just want you to understand which direction this graph is going. So at pi/6, I get a value of 2. Well, pi/6 is kind of right in there. So I have a point up here at 2. And then 5 pi/6, same thing. That's kind of close to pi. I have a point up there. So that's just helping you with the direction. What your graph looks like, it kind of looks like a bunch of little parabolas. You follow the asymptotes, and it should be nice and curved. So from -1, what direction do you think it's going to go? Down, yes. I'm not going to make you plot any other points. You can just follow the shape. So guys, if you know how to graph sine, you know how to graph cosecant. And I would actually recommend that whenever you're graphing cosecant, do all of the translations, every shift, stretch, period change, all of that with sine. Draw in the sine curve, and then your very last step, make it cosecant. It's just easier. Sine is very simple to draw. That way you don't have to worry about where your asymptotes go until the end. And do you guys see how the asymptotes, they go through that midline? Okay. If your graph shifts up or down, the undefined parts are still what was on the midline. Okay, it's not what now is on 0, it'll be what was on the midline, or is on the midline. We'll do some examples like that too. All right, let's fill in these couple of blanks down below. We'll start at the bottom, actually. What do you think the period is for cosecant? How long until it starts repeating? Pi or 2 pi? So for pi, if it was just pi, we would see this and this. Okay, so it is still 2 pi, which makes sense. It's the same as sine. What about your range? We'll do an interval notation. How far down does cosecant go? Okay, and then it comes up to, and it jumps and starts again. Yes. So your range, -infinity to -1, 1 to infinity. Okay. All right. Your domain is a little uglier to write. Because we can see, well, it can't equal 0, it can't equal pi, it can't equal 2 pi. It's going to keep going, okay? It can't equal 3 pi, 4 pi. You can't list everything. So your domain we're going to do in set notation. So it's a squiggly bracket, x such that x is an element of the reals. Yeah. Oh, yeah, a lot of notation. But x cannot equal pi k. And I'll explain that. Can you guys see that okay? Is the color bad? Let me do it in a different color. vertical line means such that x is an element of the reals, comma, x cannot equal I k. Let me see that now. Okay. This is just the way you have to write set notation. We start to get a lot pickier about notation in pre-calc honors because it really matters in calculus.
You don't have to say K is an integer or something like that?
Nope, not for right now. You're okay. K stands for integers. So you're fine. So what K is any integer. Integers are 0, 1, 2, -1, -2. So any multiple of pi, we know x will not have a value there. Okay? All right. Questions? Okay, let's turn the page. All right, I want you to try to graph secant. So I don't care if you fill in the chart or not, that's completely up to you. Over here, I want you to graph cosine and then graph secant. And I know the directions say -pi to pi, but let's do what we've been doing and stick with our -2pi to 2pi. What do you think? Do you need to label the x-axis? Yes, you do. Absolutely. All right, so we'll give you some time to work on that. All right, guys, let's look at it. All right, so cosine looks like my blue graph. Okay, everyone's okay with cosine, right? To make it secant, then, we are going to think about our asymptotes. Are we okay with those being at the zeros? Yes? Okay. Then they overlap the ones and negative ones. And then you were just drawing your parabolas. Guys, your parabola goes away from the cosine graph. You're never going to draw a parabola, not really a parabola, but you know what I mean, that shape that crosses over your cosine or sine graph. So this one, you only see half of it is going up. This one is down. Up. Down. And half of it up. Questions on the graph? Again, anytime you graph secant, I would do everything with cosine first. Okay, so like if we did pi over 3 is the easiest one for cosine. That's a half. For secant, that would be 2. So pi over 3 is right here. So you're up there too. If you went over here to negative pi over 3, that's still positive 2 because that's the fourth quadrant. Does that help? Okay. All right, guys. Again, let's start at the bottom for our blanks here. What is the period for secant? Okay. What about the range? Good. All right, our domain notation, x, such that x is an element of the reals. X cannot equal hearing a lot of things.
2k plus 1 is
Ooh, I think you're making that more complicated than we need to. Okay, the first one is at pi over 2. The next one is at 3 pi over 2, right? We can't just say pi over 2 times k, though, because that's going to give you things like pi and 2 pi, and that's not true. So we can say pi over 2 because that's where the first one is, plus how far is it between your asymptotes? So plus pi k.
That's what it is. If you simplify it.
That's why I said you're making it more complicated than you have to.
Simplify it, sir.
Yeah, I mean, like,
You're not wrong, you're just making it harder than it needs to be.
Yeah.
And guys, really, that's what we did on the last one. But think about it, where was our first asymptote? 0, so 0 plus pi k. Okay, it's the same thing. It's just you had a 0 to begin with. Okay, so we now know secant and cosecant graphs, right? Sort of. Might want to practice those. Now we get to do tangent and cotangent.
Wait, but we have a graph. Oh.
That's like all right, guys, fill in your chart for me. Tangent in the first column, cotangent in the second column. So what is the tangent of 0? Remember, it's y over x. At 0, your ordered pair is 1, 0. 0. But what is cotangent there? Remember, this one's y over x. Okay. All right, you're off to a good start. Fill in the rest of your chart. Go ahead and check up here when you're done. You guys, hopefully you're starting to see these patterns. Anything with over 6, I know tangent is root 3 over 3, so there and there. You just got to figure out your signs. Cotangent will be that at the over 3s, there and there. And these, you guys see the patterns here? It's the same answers over and over. You got to get to a point where you aren't actually doing y over x every time I ask you for a tangent value. I know we're not there yet. It takes a little time. Okay, so we're going to graph the first one. And guys, I'm going to change up our labels this time. I'm only going to go out to pi. Okay, so that means this would be pi over 4, pi over 2, 3 pi over 4. Any guess why I did that? Yeah. Okay, Okay. The period is high. Very good. Yes, the period has changed. So, all right, so let's plot some of the points we have. So what is the tangent of 0? 0. Okay, so that's your first point on the graph. Okay, we actually have the tangent of pi over 4. What is that going to equal? 1. Good. So I can put that point too. What about pi over 2? What am I going to be drawing? Asymptote. 3 pi over 4? What about a pi? 0. Okay. It's a good start. We need a little bit more for our graph. So let's think about the pattern here. It looks like asymptote, 1, 0. What do you think is coming next? Or negative 1, okay? Think about it if we go to negative pi over 4 on your circle. What is the tangent of negative pi over 4? Negative 1, yeah. What if I go to negative pi over 2? What's going to happen? Asymptote, yes. Okay. You can think about it or follow the pattern. What's going to happen at negative 3 pi over 4? 1. And what's going to happen at negative pi? 0. Okay, so we have more points now. I cannot just connect these in a straight line. Okay, it's not linear. That would just run right into your asymptotes, and that's not going to work. So, this is what they look like. It almost looks cubic, okay? But then there's a whole bunch of them. Make sure they follow your asymptotes, okay? Don't draw them so they're going to run right into your asymptotes. Asymptotes guide your shapes. Okay? All right, you are now going to try to do cotangent. So I'll label the x-axis the same way. Kind of, yeah. It's very close. No. Still vertical asymptotes. Later we'll graph inverse tangent and inverse cotangent, and then horizontal asymptotes. But not yet. Try. Don't be afraid to try it. Maybe try it in pencil. Hey guys, you gotta make sure the shape of your graph is nice. It can't be a scribbly mess. Okay? Just you will lose points for the shape of your graph if it's not a nice curve. Well, pi over 2 is 2. Pi over 2. Yeah.
Si, senor.
No, it's okay. I just did these.
Yeah.
All right, let's put cotangent up here. Let's see in life you got 12. All right, so at 0, that's undefined, so that's where our first asymptote is, right? And then pi over 4 is 1. Pi over 2 is 0. 3 pi over 4 would be -1. And then pi is going to be another asymptote. Okay? Same thing's going to happen on the left side here. 1, 0, -1. So again, the shape, it's just kind of backwards. And I think this one's harder to draw. I don't know why. My brain doesn't work. It is not linear.
Is it like a cubic?
Yep. Gotta be a curve. Okay? How are we doing on the graph? Okay, let's go through tangent first. Let's think about your domain. Guys, please pay attention. So for tangent, and I feel like I don't have enough room, so I'm going to go up above. It is x, such that x is an element of the reals, but x cannot equal. Okay, guys, remember, tell me, where is your first asymptote? Pi over 2, and then plus. Is it a distance of pi from one to the other? No, it is pi this time. I was tricking you. You can't see it, so. Because if you look here to here, negative pi over 2 is positive pi over 2. Excellent. All right, so that is your domain. Find your first asymptote. How far is it to the next one? So pi over 2 plus pi k. What about your range? Okay. The period of tangent. Pi, yes. So tangent and cotangent are different. So when you're figuring out, like if you've got a b value in your equation, instead of doing 2 pi over b, what do you think you're going to do for tangent and cotangent? Pi over b. Just jot that down next to it if you want to. All right. Domain for cotangent. So, x, such that x is an element of the reals. Do you guys have that memorized now? Okay. X cannot equal. You can tell me where your first one is. Where is it? If you want to write the 0, you can. You don't have to. And then plus pi k. So, or you could just say cannot equal pi k first. Either way, it works. All right, range. Yep. Okay. Period of this one? High. Okay. It's almost lunch. Let's pause there. Go ahead and turn the page for me. I don't know why there's always blank sides to these pages. I don't know what happened. That's why you're packing. Okay. I want you to try to graph these three. Okay? See ya. Really clear. Okay, so work on this. Think about labeling what you're going to do. What are you going to graph first for this one? Yeah, graph it as if it says y equals sine of 2x. Maybe. And then at the end, turn it into cosecant. This one, graph it as if it says negative cosine of x minus pi over 2. Okay, so give me some time here.
I can watch with
Yes, don't forget the labels, guys. They matter.
Give you a few more minutes here, guys, then we'll put them up here on the board. So much easier than the latest value. All right, guys, let's go through the first one. I know everybody's not quite done with all of them, so let's do. So, guys, what changes on number 1? The period. Yes. What is the period of this graph going to be now? Pi. So that means my labels are going to change. So that's going to be pi. 3 pi over 4, pi over 2, pi over 4, right? Yeah? Okay, so then I'm going to graph sine. Then you need to turn it into cosine. So you've got asymptote. That is it for number 1. How many got it right? Yes? Okay. Anybody want to come up here and do number 2?
No.
Okay.
Yeah, let's go.
I don't know.
And you can rest your hand on it. It's not like a normal smartphone.
Oh, really?
Like your hand's on it, yeah. What should we do before we start graphing?
You already messed up.
No.
Label.
What should we do?
You have to label it.
You do have to label.
The x-axis,
Okay.
pi over 4. Pi over 2. 3 pi over 2.
No.
Over 4 over
Yep,
4
there
over
you go. Good save, good save.
and then pi.
Everybody wanted.
Okay, and then I label
What
it.
else do you label the y-axis?
1 and negative 1.
Oh,
Oh, 3. 3 and negative 3. Okay.
We're all watching at the same
There is an eraser.
I think it's still gonna work. It's still gonna work. Oh, then the asymptotes. Right there. Oh, this one too. Oh, just kidding.
Okay.
Where's the eraser?
So, do you see up at the top, the thing that will take an eraser, just tap that.
Eraser button.
I'm not sure if that changes.
That one.
Okay. And then push the marker against the mark.
It's a 3. Okay. And the other asymptote is right here.
Okay.
And then we got some points here, here, there, and there.
Now try to make it pretty.
Different colors.
I just meant like the line pretty.
Okay.
Oh.
Here we go.
All right.
Good job.
Yep, that works. And guys, when you graph it, you don't need to graph like beyond, you know what I mean, beyond the group there. Okay. Who wants to come do number 3? Apparently, you've been volunteered. Feel free to change colors, whatever you want to do.
Wait, this is correct. Alright, we're gonna label the x-axis. The big.
Good job.
You guys will be on the video for black.
I'll pick black. Yeah, I'll do that. Wait, why is it blue? Where are the colors? Oh, okay.
Yeah, there you
And then eraser.
Yes. All right. When I make you guys write on it, you have a new appreciation for me.
Yeah, it's not exactly. Let's go. got Lakers colors for the seating.
So you got Christmas and you got Lakers.
Yeah.
Excellent. Very nice. The only thing you would add otherwise, very good. All right, guys, so he started here. Guys. All right, he started the green graph. That is negative cosine of x minus 2. Cosine normally starts up here at 1. It got flipped and then shifted to the right by pi over 2. Okay? Then, so he did all of the shifting and everything with the cosine graph because it's much, much easier. It's a pain to draw your asymptotes and then try to shift them. Like, it's just not that fun. So do all of it with cosine first, and then your last step, just make it easier. Okay? How do we feel? Sort of okay? I don't remember if I had any more for you. We're going to do... Let's try these. So try 6 and 7 for me. This is turning the leaves. So they're a little more complicated. But again, think about, for the first one, 5 sine of all of that, okay? The second one. X-axis labeled first. Do that sign first. struggling with your x-axis labels here, guys, think about what the period is. Period is going to be 2 pi over 3. Means the fourth tick mark out the end of your period there. That's 2 pi over 3. Find the others by dividing by 3. When you're ready, guys, look up here and check. Let's see what you did. Stretch. 5.
Wait, plus 2? Oh, wait.
There's a plus 2.
Wait.
But then you've got too much. See, by the time I get to 2 pi over 3, I've got 2.5. So like, this is actually supposed to be on the y. This is supposed to be on the y, but you've got just 2.
So guys, in your packet, because we're running out of time here very quickly, there are worksheets that say homework 1.6. There's one that says 1.6 and I think one that says 1.6b. Nothing is due next time. You can start working on them. You're going to have time in class on Friday to work on them, plus some additional work, okay? So, up to you if you want to get some homework done now, or see how far you get in class on Friday. Just want to keep it so you can study. Okay. I can take them out, or you can share it. It's totally up to you. Here, hold on.